Alrighty, congratulations. You have made it to the last video. I apologize. I'm sure you're probably tired of listening to my voice right now. I'm tired of listening to it as I record these, but that's okay. This one's going to be pretty long. I I don't know how long it's going to be because I haven't run through it other than when I was writing it. So, when it's a lot longer than the 5-minute videos we'd been having previously, I'm sorry. It's so long because we're kind of combining all we've talked about so far, putting it together, and adding in a lot of new stuff. So, this is probably the most important lecture out of the lot. So hopefully you're watching it, and even if you didn't watch the other ones, I hope you watched this one. But here we go. Let's talk about loading in data, the cornerstone of what we're going to be doing. Before we can get started, we need to talk about the CSV file format. So comma separated values is what CSV stands for. It's data that is stored in a text file, but it's separated by commas. It's not really great for human reading, but is perfect for a computer to go through and parse. In this example, we're going to be using the Pokemon.csv dataset. The first thing we need to do is open the file in our program, and this can be done in one of two ways. Either PokeData is equal to or is assigned open the Pokemon.csv, or with open Pokemon.csv as PokeData. The second one is kind of better practice because it allows a code block to be executed that is reliant on the file successfully having been opened. So Python has a CSV library. It can be imported with the import CSV at the top of your file. Packages and libraries are an important tool in Python programming. They're always done via an import statement, and when you're looking up things on the internet, it will probably point you to a helpful library that you can utilize. So CSV comes with several member functions, again, called with the dot operator within the package. These functions help us work with the CSV file easily. If you want more, the docs are in that link there, so you can go look at the CSV documentation. Package and library documentation, the first time you look at it, can be a bit intimidating, but just take your time, read through, and it should make sense. We're going to talk about two of the functions first. So reader is a member function which returns a reader object. We start off with a opened file object that we want to turn into a CSV reader object. We have an assignment on the left side of the equal sign, which is what we're going to assign something done with our function call on the right hand of the sign. So it looks, ours in practice is a little different. In normal circumstances, this is essentially what's going to look like. Reader is equal to csv.reader and then pass in whatever file you opened. Ours is different. I'll talk about why in a second. And then next, which is not a member function. I know we're kind of talking about member functions and the CSV stuff. I'm sorry. It's still part of the CSV module, though. It takes our reader and assigns the next row in our data set to something. So row is equal to next of reader. More specifically, it's going to assign our header row out, so we know what the header of everything is. So let's start taking a look at this. The first thing we're going to do is import CSV. And now we'll talk about how to open it up. So you guys can probably see these are different than the examples I gave. And I'm leaving the examples as they are because in most cases, that's how you're going to do things. The data set I have chosen, which I don't think Jupyter Notebooks can open. Yep. Okay. I can't open it for the same issue we were having opening it in code. So let's go ahead and look at what I'm doing. I'm specifying an encoding to be UTF-16LE, and the more silly part of this, the delimiter. The delimiter of the file I have chosen is it's not commas. Even though it's a comma separated value file, it's tabs. So how did I know to do this? How did I figure out what I was doing? Well, I tried to run it like the example said, and I got UTF codec, can't decode byte, whatever the byte is in our file. So I was like, shoot, okay. I Googled that error, and I'll kind of show you guys the process just because this is important.
Sorry, I don't understand.
Shut up, Google. Sorry, now my Google's, now my Google's listening to me too. So let's copy this in here. And we're going to go through, and Stack Overflow, as I mentioned, great help. So tries to convert a byte array. Okay, not super helpful of an answer. So I got down to this one, encoding UTF-8 and errors ignore. I was like, I tried that, it didn't work. Then this one wasn't very helpful, but it gave me an idea. Encoding format ISO 8859-1 to solve this issue. So I'm going to just Control Z, get that encoding back in here. So that told me something. It told me that the encoding of my file probably wasn't UTF-8. So that I was like, okay, I have the file, I need to figure out the encoding. So I went out and I looked up Linux get encoding of file. How can I find the encoding of a file? Okay, file dash bi file name. I don't remember this if this is the exact command I used, but we're gonna find out. So I paste this in here, and then it's Pokemon.csv. Okay, and this is normally how these sort of things go. All right. Okay. Our instances don't have file installed. My computer had file installed. I was able to figure out the encoding of the file, and I figured out it was, get rid of you. It was UTF-ISLE whatever. For the delimiter one, I opened up the CSV and here, we'll look at it in my Visual Studio Code. So we come down here to it's not in this one because I was writing on a different thing. So let's go. This is horrible to look at, isn't it? But what we can see is there's a complete lack of commas in here. So it's safe to assume it's tab separated. So we just need to tell the delimiter that we're using tabs. And now what we're finally able to do on my glorious Pokemon data set is find the header rows. Okay. So this gives us the list of the headers. This is what each column is, and we can know which ones are pertinent to us and which ones we can ignore. Can we get a data set with a smaller data set, with fewer columns, I should say, is how it's smaller, just by understanding the header. So that's kind of a pain to read. So we want to get a better understanding of our headers. Sorry. So what we're going to do is we're going to enumerate through the header row and print out the index value of it and what the actual header is. So I'll talk about this for loop in a second. It's essentially just a for loop. It's kind of a hybrid of a for loop and a for each loop, but we'll talk about it. But that gives us all our headers. We have 54 headers. I don't really want to deal with 54 headers personally. Maybe you do, and each data set's going to be different. I'm just using the Pokemon data set because I am a nerd and I thought it would be fun for me to record with. So I apologize that you guys are forced to be along for the ride in this. But what black magic was that? If you're new to Python, it might be a bit confusing. We called the enumerate function in our for loop, which allows us to go through our list, getting both the index and value of each element in our header row. As with most everything in coding, there's multiple ways to do this. So you might remember our normal for each loops are for one variable in a list. What this is doing is we're calling the enumerate function, and it's returning two things each time we go through it. It's returning the index position and what the column header actually is. So rather than getting one thing back, we're just getting two things back, is essentially what is going on there. This is essentially the same as excuse me, I'm sorry. Voice is getting to me. It's the same as if we were doing a for loop with a range. For I in range, the length of the header row, we're going to then print out I and whatever value is stored at that index. See, this gives us the exact same thing out, but it's a little more explicit and beginner friendly in what we're actually doing. As I said, the second one's just a bit more explicit. But what all does this tell us? Why is it important to go through the steps to get the individual headers out? We need to understand our data so that we're able to actually work with it. If you just have a file and you don't understand what all is in there, you aren't able to get anything out of it because you don't know what you should be looking for. And one of the most important steps in data science is cleaning up your data. We don't need the weaknesses right now. We don't need what the abilities are. We don't need like the Japanese or anything like that. We want to clean it up so it's easier for us to understand at the end of the day. The computer can work just fine. All the examples I'm going to show later on in this will do everything just fine, but we want to do it, or the computer would do everything just fine if we left the data as is. Now we're just kind of making it easier for us. If you guys want to take a look at your data ahead of time, and you should open it up in like just a text editor. I recommend VS Code, and to figure out what the delimiters are. But you can also open up a CSV in Excel or LibreOffice or Google Sheets or whatever you like to do to open up normal spreadsheets. It'll open up your CSVs, and that will give you a better understanding. But let's start getting more into the nitty gritty. We're going to talk about the package Pandas, which is one of the go-to data science libraries in Python. Pandas can do a lot of things. For now, we're going to look at cleaning our data. So import Pandas as PD. If you haven't seen that as shorthand before, it just when we were calling CSV up above or calling member functions, it was csv.reader, right? Essentially, all this is doing is allowing us to do pd.whatever, pd.readcsv rather than pandas.readcsv. Is that 4 extra keystrokes really important? No, but over the long span of things, it does help out. So let's go ahead and get this imported. And what we want to do is close our file first before we start messing with it again and opening it up. Just make sure we don't accidentally corrupt anything. So we're going to reread it in, and we're going to open it up with Pandas this time. So this is a little different, but it's still, we need to tell it what encoding we're using, and we need to tell it what the delimiter is. And that /t thing, I said we knew it was separated by tabs. /t is the escape character for a tab character. That's how we're telling the computer the delimiter is tabs. /n is a new line. There's a few others. You might just need to look up like escape characters if you want a full list. So we're opening it up with the same quantifiers we used earlier, and we're storing it in our PokeData PD variable, and it's going to be holding a pandas data frame is the type in there. So we can do print type PokeData PD. Okay. So, as I said, pandas data frame. So what we're doing with the print PokeData PD.columns is we're getting the headers again, essentially. Pandas automatically figures out how to get the headers in. And at this stage, you're probably sitting there thinking to yourself, this is so much to remember. How am I going to do this? How did Danny know how to do all of this? Here's the dirty little secret. I Googled it as I was writing this lecture. It's been a while since I've had to use pandas or matplotlib as we're gonna use later on in the lecture, and I needed a refresher. So I knew, okay, I knew we were gonna use pandas because I've done this a little bit before. So I got how PokeData.columns. I was sitting there, I was like, okay, Python pandas get CSV header. How can I read only the header column of a panda CSV? And then I ignored all that because that looked annoying. And I ignored all of that. Pandas.c read CSV. This is the page I initially found. Somewhere in here, header would have worked too, but it also, somewhere in here I found columns is essentially where I'm going with this. And then I knew, okay, cool, I can just get the columns out from that. And I'm sorry, that explanation seemed a little disjointed, but that's kind of how the process goes. You figure out what you want to do, you start Googling around till you find something that works. I'm making it look simple now just because I don't want to waste your guys' time with the entire process, but figuring out the encoding, figuring out the delimiters took me, I don't know, a little bit of time to, just because I kept getting the errors, and like the encoding was the hard one. The delimiter, it's easy to see, it's not comma separated. Figuring out the encoding problem admittedly took a little bit, but with enough perseverance and trying different solutions until I got one that didn't give me an error, we got there. So we're going to go ahead and cut down from 55 total, because our last index was 54. We know it's +1 for our total number. From 55 in columns, let's cut it down to 5 just to get started. So we can run PokeData PD with all the columns, and this gives us a look. Well, not all the columns. The ... means it's cutting out a lot of the middle, but this is what our data looks like according to pandas, and that's accurate. This full Pokédex file is not really full. More have been released since this was last updated, but doesn't matter. This is a general idea, so we could see like the national dex number, the generation it was in, the English name, all that. It's kind of a mess ultimately, so let's clean it up. So I'm going to create a list here of columns to keep, and I'm going to put in the strings of the columns I gave earlier. So national number, generation, the English name, the primary type, and the secondary type. And this is, again, kind of black magic the first time you see it. We're taking our data frame, and we're passing it our list with only the columns we want to keep. And thanks to the power of pandas and code we don't have to write, we're getting back this clean Poke, which is just our 5 column one. We could go through and we could create a... We could do this manually, and if you really want to see how it's done manually, let me know, and I will work it through with you. It's not that hard, but when there's already tools existing to do it for us, it would be wise to, utilize those tools. So we could see our new cleaned up data. It's still 898 rows, but it's only 5 columns, which is great. We can now start doing things with it. Starting simply, let's figure out just how many Pokemon each generation has. And I've said it several times throughout these lectures. There's a variety of ways to do this, and I'm going to talk you through like different ways to do it. But our ultimate goal is we want to work smarter, not harder. We want to use the tools that are there to do things for us. So let's start off with the most simple way, the way many of you probably would be your first thought. So I want you to think for just a second, pause the video if you need. We want to go through, each Pokemon has a generation number, they're Roman numerals. And we want to know how many are in each generation. How do you have an idea of how you would do that? Maybe, maybe not. It probably depends on how experienced coding you are. Maybe you're sitting there thinking this is way too much. Don't worry, it really isn't. I promise. But let's take a look. So the first thought you might have had was, okay, I need a variable for every generation. And going back to the variable lecture when I said I don't use numbers, here we go. Wrote out the numbers. So we have 8 generations. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And we know at the start of our list, we're going to do 4. We haven't found any Pokemon in the generations yet, so they're all 0. So now let's comb through our cleaned up data. And again, this isn't necessarily something you might have known how to do, and that's fair because I didn't either. So I sat down and I was like, okay, let's do womp womp. Is there? Nope, there isn't an insert. Okay. I knew I wanted every row in our data frame. The issue was it was a data frame. So normally I would do like 4 row in clean Poke. That didn't really work out. So it's like, okay, I started Googling pandas data frame, go through each row. And it came back with the iterate rows function, probably in the same web page I just closed out. And it does kind of similar to what enumerate does. It gives us our index, which I don't really care about. You can see I'm not using it. And then it gives us our row as a list, which is good because we know the definitive address of what we're looking for right now. So ignore that very left-hand column. That's just generated. National number is index 0, generations 1, English is 2, etc. So we know at row, the list, we can get element at index 1, and that's going to be our generation. So then we know, okay, we want to count for each one we find of the generation. So we can create a nice if-else setup here, going through every single row, and we can check if it matches, okay, is it generation 1, generation 2, generation 3, generation 4, etc. And when we find a match, we increment the correct variable. Then we go through and we print out just all the generations. Generation 1, 151, Kanto 151, Johto 100, Hoenn 135, Sinnoh 107, Unova 156, Kalos 72, Alola 88, and Galar is 89. Those are all right. But that's a lot of typing. I was getting bored kind of typing that out. How can we make this easier? So one improvement we can do is lists. Rather than, excuse me. Rather than an individual variable for every generation, we just have a list with 8 spots in it, and we set those all to integer values of 0, and then we can go through and increment them in a similar fashion. The generation number -1 is its position in the list. So we can do the same thing for count in the range, the length of the generations. We can say generation %d. So this is called an F string, a format string. Essentially what I'm doing is I'm saying, hey, in this string, I'm going to feed you in an outside number. And then this %, that's what the %d is saying. It's expecting a number. Then outside we have the %count +1. That's the number we're feeding in. The count we're on is going to be 0, 1 through 7, but generations are 1 through 8. We're incrementing it by 1. Then we're just getting the counts. Okay, so we get... Oh. My bad. Forgot to rerun this. Man, you guys let me get away with it for so long, even though you can't tell me I'm doing dumb things. Went one too far. Okay. That gives us the exact same numbers as above and a little more concise. Same result, less typing. But there's better ways to do it. We don't even need to declare the list or the 8 variables at the start. We're going to talk about very quickly Python dictionaries, which are my favorite data structure. They store 2 values, a key and a value pair. So we can make the generations the key, quote unquote, and then count the values. So this is going through, again, we're using the iterate rows, for I and the row. What we're doing is we're checking to see if the generation 1, 2, 3, etc. is already in our dictionary. We're going to use that key, whatever key we found, and increment its value by 1. Otherwise, we're just going to take our dictionary, put that key into it, because remember, row bracket of 1 is just going to be like I, double I, triple I, IV, V, etc. And we're going to set it equal to 1. We're putting it in for the first time, so it's only 1 element. We can run this through just fine, and nice and concisely, we can get all of that. And that's a lot shorter than where we started out. So that's what, 1, 2, 3, 4, 5, 6, 7 lines of code compared to our probably 20, 30-ish lines we had up here. Nice and concise. That's a lot cleaner than what we had used initially. But it's almost trivial right now. But we're talking about working smarter, not harder, using the right tools for the job. And we have pandas. We know pandas is the right tool. So built-in pandas counting. We have shown how to manually count things, but can pandas count for us? Values count is a function that seems to be the way to go. Again, I sat there, I was like, okay, I want Panda to count me up some functions. What am I going to do? Googled it, came across this documentation. So let's talk through what this is doing. We are pulling out just the single column of generations from our clean Poke data. We are then counting the occurrences of each, and then we're doing the dot sort index, which again I googled for, to get it in the correct generational order. So what I was getting first, after I'd found the value counts, it puts it out in a random order. And that's fine, but it's not as nice as getting it sorted by the index being what it pulled out of the generation, and printing it out. Look at that. Nice and concise. From what our best attempt was 7 lines is down to 1 line. It's great. So that gives us a count of everything in 1 line. The sort index ensures that we have the correct generational order. So that helps us understand our data, and it gives us a nice textual representation of everything. But what if we want visual representations? We want to get the collated data out, but what we want is a more visual representation. At the end of the 6 weeks, a research paper is going to be written. It's going to be turned in. And most research papers are going to have graphics of some kinds. Pandas has the built-in ability to generate graphs, or we can use a package called matplotlib, which we're going to talk about both. The spoiler alert being, Pandas just uses matplotlib to do all of this anyway, so we're going to talk about matplotlib so we can get it. This will allow us to generate fantastic graphics, pause for laughter sort of thing, but it's just a great way to represent the data. So let's start with a bar graph of how many Pokemon were added by each generation using pandas. So this gets messy to read. Python, there's where the new insert cell above, insert cell below is. Okay, well, we'll go back to what I was going to talk about. Python one-liners are famous because you can do silly things in one line, but this gets hard to read. So you think of it working out from in left to right on what we're operating on. So, okay, we know first things first, we have our list of just the generation columns. So 151 with I, 100 with II, etc. And then we're getting the counts of all of those along with I. So we're getting it's key value again. The key being the generation and the value being the counts is essentially what value counts is doing. So we get that, and then we're getting that sorted based off of what the key is. And then finally plot. We're calling the plot part of pandas, more specifically of matplotlib, and then dot bar, we're telling it we want a bar graph. That's a mess the first time you see it, and I don't expect any of you to take a look at that for the very first time and be like, this makes perfect sense, because it objectively doesn't until you've looked at it more closely a bit more. So we can see we have our nice bar graph of generation 1, 2, 3, 4, etc., and how many Pokemon were introduced in each generation. And what we could see is matplotlib, axes, whatever. That's just telling us it's using matplotlib. So you probably saw that before I pointed it out, but if not, we're just using matplotlib. So let's go ahead and take a look at matplotlib for a more granular control. So we're going to do the same sort of thing as we did up above here. We're going to get our sorted generation counts. We're going to get this based off of the first three steps. Pulling only the gen column, counting all the values, and then sorting it out. And then we're going to plot that. This time we're telling it it's a bar graph. And this ROT, all that's doing is making 1, 2, 3 the right way around. So that does it. What if we get silly and we say this, Control C, and Control C. And it works, and ta-da! We have the exact same graph done again in a silly one-liner. There's schools of thoughts to doing it different ways. So one group of people will say this top one's more explicit because it we get the cleaned gen counts out. The bottom ones say don't waste time declaring a variable you're only going to use once when you don't need to do it. At the beginning, it's a lot better and easier to do everything in a single variable. So break all of these one-liner dot statements out into step by step because that just helps you understand what's really going on a lot more explicitly. But yeah, that gives it to us. So let's do some other graphing. Matplotlib gives us the same graph as just pandas did, but let's get a more complex graph. Let's say we want a pie chart of the primary types. So we're going to do a similar thing. This time we're going to take a look at the primary type column, and we're going to get the value counts. And I don't really care how it's sorted this time around. So it defaults to sorting it from most to least primary types. And we're just printing that out now. So we can see water has the most Pokemon with the primary type, and flying has the fewest with only 7. So what we're going to do is now we take that and we plot it, and we want the kind to be a pie graph. So this auto-picked thing with a regex expression is just getting the percentages. So again, I did... very first thing I did was, okay, primary type counts dot plot kind pie. Gotta run this first. That's the danger with Jupyter Notebooks. You can run things, and I got that you can run things without their previous previous boxes being yeah, being run and you get into danger. So I ran that. I was like, well, what is the use of a pie graph if I don't have the column? So I went on yet another Google adventure and found, okay, this is how I add percentages to a um, matplotlib pie chart. And I don't think I actually ran the don't think I actually ran that, but it's been working just fine regardless, so whatever. Again, we're just importing it as a shorthand, so it's easier to do the... We haven't done any .plts yet, but that's just kind of how it works. So now we're at the end of this lecture and the lectures I'm giving until more are needed. So now it's your turn. We've covered a lot of the basics, and I want you guys to go start messing around. The best way to learn programming languages and learn what we're doing is by experimenting and doing it yourself. So we've learned how to kind of mess with our data and how to apply it to the Pokemon data. We've learned some various techniques that we utilized in here. You might need to make a new set with different columns. So when we go up to our when we go up here to clean, you might need to add like is legendary or something like that, or maybe you want to use all of them. You know the indices of each header, so we didn't need to clean it, but that's okay. So just to give you guys some ideas of what to do, and you can do whatever you want. This is for you. I'm not gonna grade you on anything, but try to generate graphs or figure out like what percentage of Pokemon are legendaries versus what aren't. Are there any type combinations that don't exist? So for those of you who aren't aware, Pokemon have either one or two types, a primary type, and sometimes an optional secondary type. So go through and try to figure out... so the types are water, normal, grass, etc. Try to figure out if there's a combination of either like water, grass, there is, or bug, psychic, or something like that. Like rock electric, I don't think there is one, but I don't remember off the top of my head. But try to find what type combinations there are, and then by process of elimination, what ones there aren't. What percentage of Pokemon only have a single type versus have multi-typing? At what level do Pokemon most commonly evolve? And how many Pokemon are there that aren't part of an evolution chain? Just if you have any questions on that, just let me know. Or if you want to mess with a different data set, that's perfectly great too. It doesn't matter. We're here for you. I'm here for you. So let me know after watching all of these where I wasn't clear enough, where you want more help on, and that sort of thing. So I look forward to meeting all of you, and hopefully we have a great 6 weeks.